Hello everyone, I'm Habib, and welcome to part 1 of an AP Chemistry crash course on equilibrium and everything you need to know about it. Now, let's just start with an overview of equilibrium. Chemical equilibrium is defined as the point in a reaction where the rate at which reactants transform into products is equal to the rate at which products are back into reactants. In other words, this means that the rate of the forward reaction is equal to the rate of the reverse reaction. And as you can see in the bottom left corner of the graph, chemical equilibrium is reached when the two lines meet and stay consistent with time. Also, when a reaction reaches chemical equilibrium and the rate of the forward reaction is equal to the rate of the reverse reaction, the concentrations of the products and the reactants are going to remain constant. And there are many equilibrium positions, but only one equilibrium constant, and this equilibrium constant is K. When K is larger than 1, this means that a system at equilibrium will consist of mainly products, whereas when K is smaller than 1, this means that a system at equilibrium will consist of mainly reactants. As a result, the equilibrium constant can provide a mathematical description of the equilibrium state for any reversible chemical reaction, and can also describe the proportional relationship that exists between the concentrations of the reactants and the products. Now, let's get into Le Chatelier's principle, which explains the effects of changes on a system. If a change is imposed on a system at equilibrium, the position of the equilibrium will shift in a direction that tends to reduce or counteract that change. In terms of concentration, the system will shift away from the added component. If a component is removed, the opposite effect occurs. In terms of temperature, K will change depending on the temperature change for the type of reaction. In exothermic reactions, when they're heated, K will decrease or shift the reaction to the left. And in endothermic reactions, when they're heated, K will increase or shift the reaction to the right. And lastly, in terms of pressure, the system will shift away from the added gaseous component. If a component is removed, the opposite effect occurs. However, the addition of an inert gas does not affect the equilibrium position. And lastly, decreasing the volume shifts the equilibrium toward the side with fewer moles of gas. Thank you all so much for watching. Tune into part 2 to see some example equilibrium problems that you might see on the AP exam, as well as how learning equilibrium will help you in other AP chemistry topics.